So hello everyone, welcome to the third part of the tutorial series, and we are here with the third chapter, that is language editor. In this chapter we'll be going over the some basic syntactical part of the Verilog as a programming language, as a the language. So we'll be going over things like identifiers, comments, numbering, compiler directives, etc. which in that. So let's get started with it. So first topic will be going over identifiers. Identifiers in Verilog or in any programming language generally are some variable names which we provide to variables to which we could use to denote certain values or variables, etc. In particular, variable is in any sequence of letter, digit, the dollar symbol, and underscore character, whether it is the first also the number or underscore. Identifiers are case sensitive. Some examples include this. Also, an escape sequence uh, escape identifier is a way of use including printable ASCII characters such as backslash, etc. Just some characters are not cannot use directly, while like a quotation, dot, star, which have some significance in the programming language by themselves, can be used as a symbol by using exception, that is by using a backslash and the character. And the last, okay, in Verilog HDL, there's also reserved identifiers called keyword. These are basically terms which are kept as reserved by the operators which you cannot use for our data function. Let's say, for example, outgate is a reserved with S since it has some significance, the compiler itself. Then, in addition, escape character is not treated same as keyword, because initials is distinct from the initial keyword. Comments. Comments are very useful in programming language to leave instruction or details for the future. So there are two ways of doing a long form call is a multi-line comment, which is second form comment in this. Then format. Verilog HTML is a case-sensitive language, so thereby if we are using variable name, etc., so being it capitalized will have much different meaning than without non-capitalized. Identifier differing only in the case are distinct. Verilog HDL is a free format. It corrupt constructs written across multiple lines or single line. So basically, what this line means basically that we could write the entire Verilog on a single line itself, which will work as similarly as intended. However, that is not very practical and not very readable for the end user for the program. An identifier beginning with is interpreted as a system task. Okay. aka task provides a mechanism to encapsulate the behaviors can inform different tasks. Is a specific type of behaviors can be invoked from different part of the tasks that can return zero or more value. Function is like a task that can only return one value. So there is a difference between value and the function in a task. Function can exist in zero time. Yeah, that is no delays are allowed. And tasks can have delay. So those are two of the examples of tasks and functions. And compiler directives. Compiler directives are important parts since they let us directly interface with a compiler and use certain things. Like they always begins with backcode and character and compile. Compile directive when compile remains in effect throughout the entire compilation process, which could span multiple files until a different compile directive otherwise. Some of the we'll now go over some of the common compiler directives. So let's begin with define and undef. Define directive is used for text substitution and is very much like it has defined in C programming language. As you can see, we could define it as a max percentage 32, and whenever the program would be using it, will automatically be changed with 32. And when we define something we need to remove the dimension, then we could use undef. Such we could define it with define, use it, then we'll undef, and undefine using undef. And next is conditional definition, that there is if def else and def. So if you want to define something based on what some kind of um, condition, then we use if def side. If the if this is Windows, then what we do this, else is with this, we put this something. If the Windows equal this, if Linux equal to something else, if Mac is equal to something else, like that. Then there is come default net type, because there are multiple subtype of net data type in Verilog itself. So while using, when we come to a need, we want to specify what type of net type all will include. Every time comes to manually defining it might be tedious if you're using the same only one type or one type primarily. So it is highly useful. And include directive can be used to include content of any a file inline. This file can specify relative path or with a full path. Then restore this comparator resets all the comparator to a previous value. For example, if we want to remove the value of remove this basically default net type from 1 to, let's say, the initial value, that is net. And timescale, since we have already seen this used in this chapter, earlier chapters itself. It is used to basically define time unit and time precision. Mount unconnected drive and unconnected drive and non-connected drive. And any unconnected input in module is sufficient to the difference between two directives can be put up or down. Self-define and unself-define. These two are used to mark a module as a self module. They are typically encompass a module that is shown below. Still are generally used by payload to subroutines. Value set. As in digital, in normal programming, we get the logic can be have two values, that is 0, false, and 1, true. But in Verilog, since we're dealing with hardware, there are four types of values we could get. That is 0 or logic false. One is logic true or one, and x uh, which means unknown. Basically, if the result is unknown, we get this. And there is also high impedance. If the wires connecting something has been disconnected, then we will have high impedance. And other than there are three type of constants in log. They are integer, real, and string. Let's first go over integer. They can be written in two forms: simple decimal format and base format. Simple decimal form and integer in this form can specify the sequence of digital digit with of divine that is normal way in we write. The other thing is base notation, where basically we write how many bit of data we'll be using, what type of data, which type of value base we'll be using, and then the value. As you can see here, we have 5 bits, so I've written 5. It's octal, so we've written O, and 37 is the number. Then 4 bit to a 4 bit decimal 2, so 4D2, similar like this. Then finally, reals. Reals can be in two forms. Reals can be understood in two forms. First, decimal notation, where you can normal decimal number, and next is scientific notation, that is exponential form, which we normally use, which can be converted directly. And string. String is a sequence of character double quote. String is a basically fixed character set where a particular group of characters which can be used to denote some things. And backslash can be used inside figures. Partial characters are normally can't be used. Data types. As we have already talked about the first chapter itself, Verilog has two major data types: net type and register. Net type denotes the connection between two types, and register data types are basically the things which elements between them.